Welcome to our third webinar in the SIF ideation series. If it's your first time, welcome. If it's your third, well done. And in this one, we're focusing particularly on advanced transmission with a focus on semi and superconductors and how we can better integrate them, make them more commercially viable, and how we can sort of transform the way that we move energy on the grid in order to meet those sort of ambitious net zero needs. So next slide, please, Charlotte. I'm going to get started. I will be your host. I am a manager at Carbon Trust in the energy transition team, and I will be joined by the very capable Beth Foster from the SIF team. She's going to give you an overview on what you can expect within this webinar, as well as the overall SIF program. And we've also brought in Matt Hastings, who is the CEO at Ideonomy, and we're going to be using that for a lot of interactivity within this session to sort of tease out some of the challenge areas where you think that we need to really put some focus. And then, of course, we have an expert panel that you'll be listening to. And we have John Robbins, we have Dr. Vidi Pisapati, and then we have Dan Cutting. So they're going to join us to give us each a flavor of what they think about with energy transmission and advanced transmission, and the challenges that we're facing. Where do we see specific innovation? Again, whether it's commercialization or the technology itself and the implementation on the wider network and system. So we're going to go through the speakers. We'll get to a Q&A session, a brief Q&A session. Please use the Q&A panel. You will see it at the top of the webinar. We have also put a link for the Ideonomy session. So I'll quickly jump to Matt just now, but in the meantime, feel free to use that link to get going. And then while you hear the speakers talk, it would be great if you start putting in your problem statements, and we'll give a little bit more instruction towards the end on what we're doing there. That's the problem statement identification part. And then we'll get into the next steps where we just discuss the SIF program, what you can expect from future webinars and workshops, and how do we take ideation from this forward. So with that, Matt, if you want to give us an introduction on Ideonomy, how we'll be using it today.
Thank you very much, Masao, and lovely to see everyone. Incredibly exciting session. So my name's Matt. I'm the founder and CEO of Ideonomy AI. Ideonomy is really a problem-solving platform. We're here to help people collaborate really across sectors to try and solve shared problems. So the work that we've been doing with the SIF is really to identify particularly novel problems. So how might we ... type problem statements against three of their kind of core challenges, of which advanced transmission is one of them. And we're also here to try and identify people who wish to collaborate around some of those problems. Really trying to get to a stage where game-changing project ideas come through. So like Masao says, you'll see a link to the platform in the chat. Get logged in. You just need an email address and a password. Password has to be about 14 digits, but it doesn't need @ or hashtags or anything like that. It can all be letters. And then we'll go through the functionality of how the platform works towards the end of the session, but it's essentially a way where you can view problems, you can rank them in order of priority, you can vote to collaborate around them, you can discuss problems, and you can also add problems in. And then after that, that data will be shared with the SIF team so they can start to form collaborative clusters around some of the most high priority problems. So that's it from me for the time being. I'll be back later. I'll now hand back over to Masao.
Perfect. Thank you so much, Matt. I'm looking forward to that. So you heard it here, get your thinking caps on, because we'll be doing a little bit of problem statement identification towards the end. So just two bits of housekeeping. Please stay muted and camera off. We will have an opportunity for the Q&A, but we are only using the Q&A panel. So please use that for all of your questions for speakers or any members of the SIF team, or if you want to learn a little bit more about SIF ideation in general. But we will not be doing a sort of live discussion unmuting. Please use the panel for that. As well as if you do have any other questions afterwards, you know where to find us through either the Carbon Trust or the SIF team, and we'll be sharing a little bit of information on how to get in touch with us. So without further ado, I'll pass on to Beth to give us the sort of context of SIF and what exactly you're trying to achieve from this particular webinar.
Thanks, Masao. I really appreciate it. Hi, everyone. My name is Beth Foster. I'm one of the Energy Systems Innovation Leads here at the Strategic Innovation Fund. I'm going to spend a couple of minutes just giving you an overview of the fund and how to apply and what we do, etc., and some of the key stats. If you have any specific questions about what we do, please add them into the Q&A function at the top, and I will be monitoring it throughout this webinar and answering questions as we go. Next slide, please. So what is the Strategic Innovation Fund? Well, we're a major investment program to drive energy network innovation towards net zero. So we have a projected potential cost saving of 2.6 billion across all of the energy networks by 2035 across our projects, which also translates to a 7.1 million tonnes of CO2 in potential emission savings by 2035 as well. We funded, this number's constantly changing, but we've funded over 246 projects so far, which is around 235 million pounds of funding allocated to them. There's been 41 million pounds contributed by the people involved in the projects. And we funded over 300 different organisations and well over 100 small and medium enterprises. We are set up and designed to help energy network users and consumers. So that's the aim of some of the projects. So whatever we do and whatever we fund, it's got to have a net benefit to the end user and ultimately the bill payers, because they are the people who are paying for this innovation. Next slide, please. What is our mission? Well, we want to diversify the pipeline that come through and develop some of these innovation technologies. So we want people from different industries who are able to think outside the box and propose new ideas that perhaps the sector haven't thought of before. We need evidence-based submissions, so good quality bids, good quality assumptions made in your CBAs. We want to fund transformational projects. We want it to have a nationally significant impact on the energy networks. It's got to be commercial, so it's got to bring a return back to the energy network bill payers. It's got to align with existing decarbonisation plans across other sectors. And you've got to be agile and responsive in your delivery approach. Now, when I talk about an agile approach, we have 3 phases in our funding. So discovery projects will fund up to 150k. Those are typically feasibility style projects. We then have the alpha projects where companies start to model what the MVP would look like. And then the beta projects, there's actually no cap on funding for that, but approximately the projects are around 10 million pounds. And that's when we start to look at live demonstrators and deployment strategies for the technologies. Next slide, please. Cross-cutting considerations. So when you're putting your bids together, please think about some of these areas. Please make sure that the bid is focused on the consumer and the customer. How are you going to make a difference to energy network users? Think about the maturity of the supply chain. Think about how scalable your innovation could be and the potential impacts if it was rolled out across the whole of GB, not just the network that you're partnering with. Think about the skills and capability that are required in your project and the upskilling programs that might be needed. Think about a digital approach. So you may have heard or seen in the news, Ofgem are really pushing for digital technologies and digital innovations to come in and support some of the physical innovations as well. Consider how you would share your learning with other industries, other networks to support rollout across GB. And then also think about energy resilience as well. How resilient would this be to a changing regulatory landscape, environmental landscape, or commercial landscape? Next slide, please. So this is the first challenge out of 7 that we're running for the next 2 years. I'm not going to go through each one in detail, but we are in our moonshot challenge at the moment. And I say moonshot because this is probably the most ambitious one out of the 7 in terms of we're really looking for those blue sky thinking feasibility studies to come through the pipeline in this one. The other challenges may have slightly different focus. They may be more operational. They may be more centered around strategies to engage people and users. So for example, challenge 2 is dynamic modeling. So we're looking at grid simulation techniques. We also want to look at high energy demand point integration, so particularly data centers. How do we integrate those with other utilities? There's consumer-centric grid expansion, so we're looking at the not just the technology, just not the technological strategies to expand the grid, but the people strategies too. System visibility and control. I think that anyone who's been working in the energy space for a long time will know that this has been a challenge for quite a long time. A new and perhaps unusual one is the green gas challenge. So how do we support gas networks to inject more biomethane and bio-SNG into their networks without compromising existing infrastructure? And then finally, challenge 7, which is the one that ties it all together, is whole system optimization. How do we work with other utilities to create the best plans moving forward as we approach closer to that 2035 and 2050 deadlines? Next slide, please. Super. I'm going to hand back to Marcel, who's going to run you through a few more details about this specific challenge.
Thanks so much, Beth. So in terms of the challenge itself, next slide, please. We're, for this webinar, giving particular focus on, and that does not mean that the priorities for the overall challenge can't encompass other areas. We are, next slide, Charlotte, sorry. We are looking at, the general problem is the integration. We're looking at high electrification. We have a lot of demand to meet. We have sort of critical infrastructure to address, and we need to get the power in a more advanced way, as it were. So we're looking at what's breakthroughs can we get with current infrastructure, as well as advanced technologies that can be on top or replace that infrastructure in order to sort of meet the needs that we're seeing as we get to clean power 2030 or net zero 2050. How do we make it more commercially viable? How do we integrate it better? Is there supply chain risk? How do we get it more coordinated across the networks, distribution or transmission? So we are looking at how we address these rising sort of demand forecasts, the technologies that are needed to get there, with a particular focus on the sort of advanced transmission technologies such as semi and superconducting cables or other elements within that technology realm. Again, we just want to clarify this is not limited, even though we have speakers that may have a particular focus. I'm seeing some questions come through. We are not limited only to those particular aspects. This is just to give a flavor of some of the challenges that we have to set the scene. The ideation continues well beyond this. And this is not saying that these are only the priority areas that we're going to have within this particular challenge. Next slide, please. So if we're looking at the gaps, we need to have a smart energy system. We're looking for the better integration of these solutions. And then we're trying to overcome these barriers, whether it be a sort of large scale testing and validation, moving it out of a lab setting. Now, we also need to keep and realize that, we have a lot of OEMs that do a lot of R&D in this space. And it's not necessarily to take ownership of that or do that through the SIF. We're trying to see how the technologies can be better implemented, made more cost effective, look at whether we can model that scale out across the UK and see what the impact may be on the consumers. That's where we're trying to look at the certain challenges here, not necessarily spending 10 years, billions of dollars in the sort of OEM side of it with the deployment and R&D. So when we're looking at this webinar, as I mentioned, our focus is less on the wireless transmission. SIF is exploring that through other routes. In the ideation process, we're putting more focus on how we can get the advanced integration of these technologies, and then how do we do the validation or demonstration of superconducting technologies if you're looking at cabling or other sort of technologies within PEMs or any sort of transmission technology where we're trying to get it at scale at a low loss rate to electricity networks. So with that, I think it is better probably if we give you a flavor of what has actually been done in this space. And then from there, we'll transition into the speakers. So back to you, Beth.
Thank you. And thank you to some of you who've been starting to post in the chats. I was reading through them. So some of the projects that have come through which are related to this, they're actually, all 3 of them that have been brought up recently are from NGET. So one is the assessment of superconducting technologies for standards development. Another is called SCOL, superconductor overhead lines, and SCADAN, superconductor applications for dense energy transmission. Now, these are all, these are all superconductor focused, but this challenge is not limited to superconductors. Anything that will enable us to meet the aim of the challenge, which is to enhance grid performance, is all relevant. We're really looking at those, feasibility studies of new technologies. If you're interested in any of the projects that are listed here, please drop me an email or drop a message in the chat and I can provide links to more details and some of the documentation that have come out of these projects. Super, next slide, please. Super. Now, I am delighted to hand over to our first speaker of an exceptional panel, who is John Robbins, who's the Head of Business Development at the CSA Catapult. John, over to you.
Hi, yeah, good morning, everybody. Actually, it's really nice to see a lot of familiar and friendly names down in the attendee list of this today, organisations that we've worked with. If you'd like to skip ahead a slide, maybe skip to the next one, actually, if you can, please. Thank you. Yes, I'm going to go through a few points today. One, just I'm going to walk through a little bit about who the CSA Catapult are and where we sit in the Catapult network. Because I'm kind of aware that I know there's some of you on here that we have worked directly with and very familiar with who Catapults are and who CSA are, but that might not be everybody. So I'll just do an introduction there. And then I will just talk through one of the internal case study projects actually that we've done that's very relevant around solid state transformers and the benefits that we think that that can bring, especially to things like this challenge. And then there's just a quick summary at the end, if that's okay. So if you could skip forward, please. Thank you. So CSA Catapult, we're the newest of the 9 catapults funded out of Innovate UK, and we make up the broader catapult network across the country, where I think at the moment we're sitting around about collectively just over 5,000 employees, and we focus on a number of different technology areas. And if you can move to the next slide. Yeah, so CSA Catapult, we focus very much on the adoption of compound semiconductors and the application of, but more importantly, we focus around the commercialization. And we do that as a research and technology organisation. We're actually based down in South Wales, and I'll come to where we have other locations around the UK as well, where we are particularly clustered. And we look at anything, so we take everything right through from sort of that mid or low to mid TRLs. And if you move to the next slide, I've got some words on there around this as well. So we sit in that gap between academia and industry, and we normally work on projects TRL sort of 3, 4 up to about 5, 6. We can sit either side of that and go slightly lower. We do a number of EPSRC projects which take us down into that more fundamental research, or we can work a lot closer into the industrialization side of it. And the real purpose for Catapult is, as I say, we do primary research, we do that industrialization, and the whole Catapult ethos and model really is one central investment. So as I mentioned, we're in year 8 now. We're the newest of all the catapults and very technology focused. And the purpose of that investment is that we have open access labs, and so that we can really help with SMEs and industrial scale up and that process development and research. So if you look at what we do around sort of advanced packaging, we will do process design and development, but only up to sort of 10, 15 parts. And that's where we work very much across consortiums across the UK. So we should be there as an enabler for other UK businesses to actually go to route to market and commercialization. Our role is not to do that. We're there very much to help accelerate the development of other organizations. If you can skip to my next slide, please. And we do this in one of 2 main ways, really. We can work with companies on that direct commercial basis. It's a lot more what you're sort of traditionally used to, quote and sell, where we will do access to labs, through working together on projects, either around characterization, validation, integration, or just pure design work. Where we do most of our work is actually in the collaborative research and development space, because that's where we can have the most impact with UK businesses and UK organisations, and we can work internationally, but if we do that, we always make sure that there's a UK company presence in there as well. That's where, as an organisation, we sit as that neutral convener of the supply chain. We will work right through from SMEs up to large organisations, pull together the supply chain, help with the bid forming, scoping of projects, and even we can go down to sort of project management of them and go into a more competitively funded landscape. And that's where we've done the majority of our projects over the 8 years that we've been going. If you can skip forward one more slide. Because we look at compound semiconductors, we're not actually just focused on high power electronics. It's one of the areas that we work in, and we've done a number of projects and very successful track record. I'm happy to talk to anybody that's on here today about this. But we also do work around a number of technology areas as well, and these are all aligned to the applications of compound semiconductors. I think for this call, and the most relevant, obviously, is the power electronics, and there's some details there around the lab and what we've got. And anyone is always welcome to come down to Newport in Wales to have a look around. The other area that is actually developing, and probably as important, if not more so in some areas, is around the work that we are doing in the advanced packaging as well. So we take anything from single device or single chip right through, and there we've got through things like the Driving the Electric Revolution Challenge, funding into ceramic and additive manufacturing as well. So that really allows us to do that. I think for us to be able to actually utilise the benefits of what we're doing in the compound semiconductor devices, if you start to look at the packaging of this and then the application of that, right? We have applications in the name of the catapult for a very specific reason. So we sit post fab, and we look very much at the application side of things. So we don't sit that very early part of the process development. Skip forward one more for me, please. Yeah. So we started out based in Newport in South Wales. Over the last 2 years, we've actually grown our presence in terms of physical locations across the UK. First of these was the Future Telecoms Hub down in Bristol, very much aligned with the cluster there, and then one up in the northeast and based in Durham, which again is looking at the advanced use of semiconductor technologies in various industries, things like telecoms, satellite comms. The one that I think is probably, again, very relevant to this is the one up in Glasgow, where we are absolutely there to be able to work with the supply chain across there. And I think it's really good to see Dan from PNDC later on in this presentation, because it's an organisation that we work very closely with, especially in things like high power testing capabilities that we don't have, and we absolutely use and work with the supply chain for that. And once we've got devices designed and built that we need to do testing and validation of, so absolutely very strong partner network, especially up in the Glasgow area. Next slide, please. I'm going to move on to one of the case studies that we've been doing. We've looked at this in twofold. One, we've done engineering projects, but also we've been doing a market intelligence, market analysis around solid state transformers in exactly the market space and the applications that we're looking at today. We're expecting that to be published in the very near future. So yeah, hopefully we can share a link around to that when that comes along. And the reason that I mentioned how we do commercial projects, how we do collaborative projects, but we also do a number of internal projects. And the real purpose for doing these is not so that we have a capability or a product that we have ourselves. It's to enable us to be able to really complement what organisations and businesses around the industry in the UK are doing, because it allows us to build up knowledge, build up demonstrators, and absolutely build up the capability, so that when we are in collaborative projects, we've got something that we've got track record that we can bring into it, rather than we're just starting afresh, and we can start to sort of build up some platforms that we can use there. And this is an example of one of them. And the reason that we focused on SSTs in terms of their application in grid solutions is actually they start to bring additional functionality that we didn't have before. So they start to bring things like real-time voltage regulation, harmonic filtering, reactive power compensation. Yes, SST on the simple surface of it is more expensive than the current solution, but actually if you start to look at a platform saving and a system cost, actually where we can start to bring multiple functionality and devices into one thing, then actually that starts to bring an overall net cost saving. And being able to do all this actually starts to think like we can start to have clear and direct impact on things about network stability, absolutely becoming a rising issue, especially with the penetration of things like renewables and just fluctuating demand. I know down my street, I see more and more people charging their cars overnight, right? So actually being able to do that and the flexibility that comes in from solid state transformers is great. Also, an extra feature that you start to get from if you start to look at this setup is things like bidirectional power flow. SSTs have this great ability where you now can have enabled controlled two-way power flow, and this is crucial for integrated distributed energy resources. So things like rooftop solar, batteries, EVs, and it allows to support things like active network management. All very good control, and SSTs are an absolute enabler for that. And the real beauty of this, and as I say, going back to the platform, and I think if you start to look at where we want to go in the next few years around this, it is a very modular and flexible solution. And so you can scale network, you can scale this scale the setup and actually start to get real benefits from it. On this slide, actually what I'm showing is that we developed a 100 kilowatt solid state transformer cell. This is the next generation alternative to traditional grid transformers. System uses a neutral point clamped dual active bridge architecture. It's always a nice mouthful for me to say, but this topology allows us to offer a precise control of power flow and better efficiency and the ability to integrate, as I say, back into that modular system in there. At the heart of this, silicon carbide devices. Very good partnerships with the likes of Classic in the UK as well to be able to start to deliver and offer these solutions. If you move on to my next slide, some of the outputs that we found from this, absolutely, our lab trials actually kind of passed our expectations here. Right? Even at partial loads, we're starting to see high 90% efficiencies in there, and it really gives good notable benefit, especially around the things like complex switching behavior and the thermal dynamics. I think, as I mentioned on the previous slide, but didn't actually say out loud, we spend quite a lot of time looking at how we manage the heat transmission and the heat flow of the devices in there. Absolutely validated the outcomes of this through hardware testing, and that allowed us to really ensure that consistency between theoretical design and real world performance. And actually, just beyond the numbers, it's allowed us, as I say, to build that really critical capability in the catapult. We've got a lot of expertise, especially in silicon carbide switching, and this is on the back of a number of projects that we've done in different market segments, things like escape in automotive and many more use cases that we can pull in. I think looking forward, actually, if you move to the next slide for me, I think it kind of shows where, on the basis of this, we can start to look forward to where we go next. And that's where our future focus is really to build on this foundation. We're going to probably aim to develop a 3-level bidirectional converter using 1.2 kV silicon carbide devices. But actually, where it's modular and scalable, we can absolutely start to take that to 1.7, 2 kV and 3 kV, and hopefully beyond that. Good application areas, especially the ones that we see that are probably the most challenging and demanding, vehicle to grid, and renewable integrations and just smarter grids. But actually, where we're based in Newport in Wales, I think we're now getting our third data centre built on the same industrial estate, right? The high demands that we're starting to see for that, I think this is quite good. This is very much where we want to go in the future. This is absolutely the kind of projects that we want to be talking to people about to partner on, ideally through calls like this one. so that we can help with fundamental research and enabling then somebody else to actually commercialize this and take it to market. If you can switch to my last slide, I believe it is. I'm not too sure how I was doing in terms of time-wise. And this is just generally, why should you work with us? Obviously, we're endorsed. We've got really good access to the supply chain, and that element of neutral supply chain can work on there. And I think just our work in the advanced power electronics, especially around sort of AMPC bidirectional converters, really does align with what this call's got in store. And I think that's my last slide. So I will stop there. Contact details are here. Obviously, you can reach out via this for if you want to go deeper and talk more.
Thanks so much, John, for that flavor of what Catapult is doing in the area. Really good to see that work. Thanks so much. So moving on, before we get to our next speaker, just a reminder that you can put your questions for the speakers or the SIF team within the Q&A panel. And also we've pinned the link to Ideonomy at the top if you want to get started in advance, say a problem statement clicks in your idea while you hear one of the speakers, head all over there through the link, but we will have Matt back in to explain it later on. So without any more waiting, we'll get to Vidi Pisapati, who is a senior lecturer in high voltage engineering, and he's going to give us a little bit more information on what he's doing at the University of Manchester. So over to you, Vidi.
Thanks, Michelle. Morning, everyone. So just a very quick presentation today of kind of what we do at the university, what my role is, and I'll then try and tie that back into some of the projects that we've worked on superconductivity, along with the partners within SIF, with NGET being the lead within the projects. Can I go to the next slide, please? So the project is today's presentation is effectively just to kind of highlight how we help with knowledge exchange between what we learn in research and how we actually utilize that to the end product or the consumer. I'm a senior lecturer in high voltage engineering, but I'm also a knowledge exchange fellow. About 15 years ago, I started my career in actually de-risking products, and that right now has led me into different kind of areas, which I'll kind of speak through on the presentation. Can we move to the next slide, please? So in terms of expertise, the kind of knowledge exchange, I put this in Google, and it says translating university knowledge and research into practical impact. So what does that actually mean? Well, effectively, we try and maximize what we learn from our research and apply that to end products. And especially in the space of developing assurance to the end user from a product. And I find I sit in the middle of that effectively. So, and that's why I call knowledge exchange between a product and the end user and accelerating the technology. The T-pylon is an example where I worked on the product developer and the end user to see how we can de-risk the product and push it quicker onto the network. Now, I must highlight, these are some of the areas that I work in, but there are more. So I would basically say in standards acceleration, okay, what is there out there that you can actually apply to the product? Failure mode effective analysis and the testing support. I'll talk about that in a brief in the next slide. Do quite a lot of condition monitoring and digitization of the asset. Now we talk about digital twins right now. However, the work on digitization, FEA analysis on assets have been doing within academia for about 2 decades now. However, the resources we have right now have gone forward. So actually we can do a lot more dynamic modeling as well within the kind of FEA sections. And we also do quite a lot of high voltage testing as we have access to the labs, and all of these help in actually pushing through innovations onto the network, but not just necessarily the network. So the bigger picture for someone like an academic institution is electrification, and that's not just limited to electricity network. I must highlight that areas of myself and colleague work in these above, but we do quite a lot of system level as well. Next slide, please. So if I kind of talk about the portfolio of energy transition, these are the companies I have worked in the past and currently work with. And I use that word electrification very much so because it's not just limited to the wires and the cables that bring electricity to you right now. The rail networks, transportation, digitization, there's a lot. The energy transition actually involves quite a lot of the end user, quite a lot of companies, and we work within that space. Work with several OEMs, work with a lot of networks. This expertise is what brought me to superconductors. And as I said, the high voltage itself is not necessarily what you call just 275, 132 kV, anything over 500 volts or 1000 volts is categorized as high voltage, and that's where superconductor falls as well. The voltages can be lower. As an academic institution and an academic, I've been involved in a lot of de-risking and at different ranges and different voltage levels of the products. Next slide, please. So what University of Manchester also has is UK's largest high voltage lab. This effectively means that we can test any piece of equipment that goes onto the UK network. What you see over there is a 2 million volt impulse generator that does the transient voltages, both lightning and switching, for a 400 kV network. There is an 800 kV RMS AC test set with 2 amps. Once again, UK's network is 400 kV. That's around 230 kV RMS. That does 800,000 volts RMS, so you can push your asset up to 3 times more. We obviously also have a DC test set right now that does 600 kV DC testing as well. The lab is the largest open access within UK. It's not far from Piccadilly, actually, so it's in the city centre as well. Now, what you see here are larger voltages. However, across the door, we also have smaller labs that allow us to test material level. So down to oil, down to XLPE, down to the gas, just more material and analysis that gives you an understanding of how they fail, how they age in the future, what are your condition monitoring, what is that kind of sampling technology that you need to know if you want to keep something and want it to run for 15, 20, 30 years. So we can actually do anything from the asset level to the material level. De-risking. What I haven't actually put up in this is we also do have system level expertise. So it's actually the power and energy department at the University of Manchester. So we can actually work on material. How does that go into the asset? How does it get tested on the asset? And we also have capabilities to actually do work around the system resilience. What happens if you put a new product on the line? What does it do to the bigger system? So the idea is, from an electrical network perspective, well, actually any end user, it's not just about integrating the technology onto it. What does that have as a bigger picture? Does it have an impact on other stuff? Funnily enough, you have a network that ranges from equipment that's been installed last week to equipment that's going for 60 years. And the interaction between that is quite important. Next slide, please. So we've all seen this. So I'm not going to talk too much about a TRL level. But I think the interesting thing from a design assurance perspective is not TRL, is de-risking. You could tick TRL5, TRL6, TRL7, but might not have de-risked the product to a point where it's actually ready to go onto the network or have that assurance that the end user is ready to take. And I think that's the key here. So, and that's why I've kind of used is that TRL levels are actually de-risking. I find the TRL level very much a venture capitalist kind of ideas scenario, but I like the word de-risking because you could be de-risking it much quicker at TRL level 5 that gives the assurance to the end user to say, actually, we're at a better point. And that's why the interaction between the end user or the actual installer is actually very, very important because it needs to give confidence for it to go and do what it needs to do. Can I have the next slide, please? So everyone's again seen this, and it's interesting. If you go between TRL1 and TRL level 9, have we got enough time to get to where we need to get to? The picture on the right hand side is just to give you an idea of what you see, but there is maintenance that happens all the time. So there's a lot of things that are happening on the network actively. So the question that we get usually, our assets, how are they aging? And so you have to kind of think, have we got enough time to push this through? And I think that's where the collaboration between different companies is very, very important. So we try, and that's why I use the word knowledge exchange. So it's actually, we actually the product of tomorrow based on the knowledge that we've gained from before. And that's actually the key here. So you have to, and we're quite active in talking to different people. Being an academic institution, that open access really helps us as well. Next slide, please. So I've kind of like that line. It's almost innovating the product of tomorrow with the knowledge and the learnings of you have today and to de-risk the technology. And the process is a full cycle, and actually understanding that bigger picture. So it's not just about, okay, I'm ready to go put this in the network. It's almost like, well, okay, you've done that. What is the next thing that can happen to it? What is it going to happen 10, 15, 20 years? So that big full picture has to come through. Unless you do that de-risking, so the TRO level doesn't necessarily associate you with that. The TRL level stops it at maybe a product, but have we got enough design assurance that we're happy for it to go and actually run consistently for the next 10, 15, 20, 30 years? Next slide, please. So I'll go into the actual project, and that's where this knowledge in superconductors applies. We've been working with the companies that you see, and the lead is National Grid. I'm not sure why the figure's not there actually of National Grid's, but National Grid is the lead partner on the project. And we've looked at different technologies on accelerating the technology onto the network. Can I have the next slide, please? So superconductors, obviously the question is, everyone kind of thought, oh, it can increase capacity, but there are other things. Can it accelerate the rest of the network? Can it build a robust network? And is there a value proposition towards it? So you cannot, it's not just about pushing more power through the wires or pushing more power through a corridor. You need to think about the bigger picture, and that's what we've been trying to do. And that's kind of bringing everyone into the consortium and de-risking this technology. Next slide, please. So I'm not a superconducting expert, and neither am I an expert in the superconducting technology. However, my knowledge on the high voltage network has brought me to this. So the basic technology of the superconducting tapes is obviously operating at extremely low temperatures within a cryostat, and you have superconducting tapes. Effectively, it is a cable system with a coolant liquid flowing through it. However, this means that you have significant complexity in the entire system, from bespoke cable joints to terminations to refrigeration. So it's not just a single asset. You have accessories and ancillary equipment that needs to be brought into the picture. Next slide, please. It's a similar story for an overhead lines. Disclaimer again, I'm not an expert in superconducting overhead lines either. However, once again, the basic technology of using the superconducting tapes exists extremely low temperature. Once again, effectively a cable with a liquid flowing through it. But once again, similar to your overhead, to your cable section, the overhead line also has similar technical challenges. Next slide, please. So we work with two partners, Veer and Supernode, who effectively have an overhead line and a cable option. One is AC, one is DC. The difficulty in looking at standardization is you've got a DC system, which is a cable, and an AC system that's actually an overhead line. So you do an agnostic solution doesn't necessarily apply. However, the point of doing this work was to understand what are the commonalities so we don't duplicate. And that has actually been a very, very interesting process, because you can almost look at it holistically and see what you can do and accelerate in those areas. Next slide, please. So what we've actually done as part of the work is we've looked at these technologies, we've kind of broken them down into significant areas, and we've identified critical assets and the pinch points that we think we want to concentrate on, looked at standards that are available, and then where the standards are not available, we've actually mapped them to anywhere that's things that are in there or in the actual literature. And we've provided some suggestions of what we want to push forward. Next slide, please. So if people talk about superconductors on the transmission line, there's actually only two standards at the moment. Well, actually only one standard and one technical brochure. And both of them are AC. There's nothing for overhead line, and there is nothing for a DC cable. So you can clearly see that there is the need of collaboration to bring these forward. Next slide, please. However, you do have significant literature, like I said, on the AC cables and the DC cables. So it's almost like understanding where do you actually bring that relevant testing or relevant assurances to allow that to the end user to say, like, we can pick on this, or this is the one that you want to develop. So there is a holistic need to look at the technology ourselves, and the complexity within this technology makes it challenging, but there's opportunities within there as well. Next slide, please. And what we've also realized within the FMEA process is you think about the asset innovation. However, there's a lot of things underneath it that you need to look at. And it's the full life cycle acceleration, not just about what it is for the asset to go on. And that's what we're probably looking into the future phases. The next slide, please. I'm hoping I'm doing okay for time. So the current process allows to accelerate technology and avoid duplication between different vendors. It's been a really good project between collaboration between NGET, the OEMs, the academic institutions, and I kind of like that word knowledge exchange in that because it's a clear example of that. Luckily, the universities sit in that middle, in that nice space. There is most certainly a need for such system to become part of optioneering. So one of the things that we probably look out for is for this to go into the system, it needs to become a part of an option. It needs to be de-risked and become one of the portfolio. Else it's not going to go. This question of are we ready to take it is always going to be there unless you de-risk it. So the next part of the work is understanding what we have to do to move forward and make sure that this is an option within everyone's catalogs. So that's me actually. The next slide is just a nice picture of the Tesla quote, but we'll wait for the questions till the end. Yeah.
Thanks so much, Vidya. Always great to end on a photo of Tesla coil to remind us why we're here. Perfect for timing. Thank you so very much for giving us a bit of overview of the work being done. Really, really helpful. And I hope it helps stimulate some of the ideas around the challenges that we're facing. And last but not least, we're going to go to Dan, who's from PNDC and has part of an organization that's done a lot of critical work in this space. So it'd be really good to hear some insights, see some of the work that you're doing, some case studies. So without further ado, over to you, Dan.
Thank you. Good morning, everybody. Thanks also to the previous speakers who've actually set the scene really nicely for some of the use cases I was going to talk about today. So if we go on to the next slide, please, and I'll just introduce, first of all, the University of Strathclyde. So Power Networks Demonstration Centre, where I'm based, is part of the University of Strathclyde. So I'm going to cover a couple of different aspects. So go on to the next slide, please. We're part of the Faculty of Engineering at Strathclyde. So Strathclyde, since its foundation, was considered to be a place of useful learning. Within the faculty, we have 9 departments. Today, I'm going to cover 2 of those who have been doing a lot of work in this area, both in terms of the grid and the development of the grid over the last few decades, but also some of the specific technologies that are called out in this challenge. So if we go on to the next slide, please. So the 2 groups I'm going to talk about today is the Institute for Energy and Environment, which is part of our electrical engineering department, and also Power Networks Demonstration Centre, where I'm based. So PNDC started off as part of the group on the left and has grown to become its own department based on a need really for us to build a kind of replica scale testing environment for grid-based applications. So between ourselves, with a kind of R&D focus and the traditional academic teams, we cover a broad range of the TRL levels, which we've talked about a little bit already this morning. But I'll go into sort of the different approaches to how we do that as we go through. Next slide, please. So just wanted to flag, we've been really involved in a number of SIF competitions to date. So just a few different press releases here over the last few years. So we're really keen to help continue the development under this initiative. Last year, the latest announcement towards the end of last year, we're involved in almost 25% of the beta projects that were announced towards the end of 2024. So if there's anything we can do to support people going forward on new proposals, please do let us know. Next slide, please. So I was having to think about the challenge and maybe just wanted to start off with kind of my thoughts on how we can leverage some of the breakthroughs elsewhere before going into some of the specific capability around the University of Strathclyde. So if we go to the next slide, please. At the top in the middle, I took a quick screenshot of the question. Down the left, I suppose we have sort of a bit of a scene setter in terms of, from a power networks perspective, where the challenges arise from in terms of the adoption of renewables over the last decade or two, and the transition to more of a distributed energy system that we have in the UK, which has been demonstrated by the ESO image on the bottom left. So I was thinking about some of the initiatives I've been involved in and aware of over the last few years. So prior to my role at PNDC, I was involved in the Driving Electric Revolution Industrialisation Centre. So there's a number of different initiatives on the go that I think we should consider, but then also a number of different sectors that I think we can draw experience from and apply it to in this area. So starting off with initiatives, there's some links in here. So if the slides are being shared afterwards, hopefully people find them useful. So DER was set up 6 or 7 years ago now, I think. And over that time, there was £80 million allocated to the project by UKRI. The impact report for that says that they did a brilliant job in leveraging that. So there's been a 16:1 ratio in terms of the investment in the power electronics, machines and drive sector. So there's an awful lot of good supply chain in the UK that can be accessed for this challenge. One of the things that was funded was the industrialization centres, which I worked on. So that's a network of a number of organisations across the UK, universities, RTOs, includes the likes of the other speakers. And there's a really big open access base of equipment and expertise that people can go to. Again, there's a link there, some really good reports on that. And then obviously the impact and the opportunity for the UK has been recognised with the UK National Semiconductor Strategy that was published. So I think there's an awful lot of activity, a really big groundswell around these technologies. So it'd be good to see how we can leverage those. And then I also wanted to touch a little bit on the sectors. So there's a lot of work going on in other sectors on semiconductors and superconducting, which are the two areas I'm going to focus on rather than the wireless element of it. So it's good to see there's Nigel from Turbo Power Systems is on the call. So some of the work that we've done with them and the work that's happening in other areas such as automotive, there's a lot of investment there that we could pull on. I've also highlighted the Advanced Propulsion Centre, so they did some really good work on the power electronics value chain, which I think is something people could have a look at and maybe spark some ideas around how some of that investment could be utilised in the energy sector. And finally, within aerospace, there's some good work going on funded by the ATI around superconductors and power electronics for high integrity applications. And obviously that has some really strong impacts in terms of both the longevity of these assets within the energy sector, but also some of the functionality that we'd expect in terms of the lifetime and how we'd monitor them, and also as things heat up, how they fare from a thermal perspective, and so on. So just a bit of my thinking around this challenge. If we go to the next slide, please, I'll maybe talk a bit about PNDC and what we're up to. So this is Power Networks Demonstration Centre. We're, as I said, part of the University of Strathclyde. Our aim really is to help accelerate commercialization of technologies across the whole energy system. So we see the whole energy system approach being, we apply that to 3 focus areas: advancement of power networks, decarbonisation of transport, and decarbonisation of heat. And there's a lot of interconnection between those. We've recently expanded to a second location, but our first location, which is on the left, is in Cumbernauld, just north of Glasgow. So that's a replica of the distribution network that we have here in the UK. So we do testing with assets at 11 kV, so it's not quite transmission level, obviously, but what a lot of the work we do feeds into wider transmission studies. And then on the right-hand side, we have a new location. It's a brand new Strathclyde building, the Advanced Net Zero Innovation Centre, where we are based. We're now going to be testing at multi-megawatt scale there. So there's some slides here on that. The one other thing to mention, as part of that location on the left, DER has funded a semiconductor scale-up packaging line. So there's an awful lot of investment in sort of pushing through the manufacturing and prototyping of semiconductor devices in the UK. And we're working, as John said earlier, closely with the CSA Catapult on how we can pull those technologies together under one roof to do prototyping, manufacturing, and then obviously the validation and testing with the NDC staff and equipment. So a lot of similarities to the other speakers, but one of the things I'd say about PNDC, the reason for us establishing these replica environments and establishing the validation equipment at scale has really been driven by industry needs. So we don't have any kind of base level funding or able to offer any funding. We are 100% working on commercial or research projects. So we have about 85% of our income is from industry. We are open access, so we have partnerships with some of the network operators. We recently announced the renewal of our UK Power Networks partnership a couple of weeks ago. But on top of that, we are open access for anyone in the network to come and work with us. So if we go to the next slide, please. There's a bit more information here. I've really just put this in here so in the pack's distributed, everyone has it. So that's there. Please do get in touch if you have any more questions on it. Next slide, please. Much the same with this one. So there's a lot of new capability. I'm desperate to tell everybody about it. Probably don't have enough time to go into the details. So it's in there. Please do get in touch. But the difference between the two facilities really is in terms of the scale of testing that we're doing. One is much more focused on the grid. And this one here is much more focused on getting up in terms of the power level, so we can do up to about 2 megawatt DC testing of assets that might be connected to the grid or other power networks in the future and other sectors like transport. If we go on to the next slide, please. So I've got some case studies of some work we've done at PNDC, and then I'm going to look back around to my Strathclyde colleagues. Again, I'm not going to get through all the detail today, but just to give a bit of a flavour of how we've approached projects that have some relevance to the functionality that things like semiconductors can provide, and our approach to that. So the first one to mention is our work on the Constellation project. So this was led by UK Power Networks. For us, we were involved in helping to be the kind of validation area for it. But the real importance of Constellation is about building in additional functionality to substations. So by looking at a substation at a local level and using the data that they have from that and connecting them to the wider network of substations, that it gives a higher level of controllability, and it can help the network reconfigure itself if we're having any issues with electricity flow. And for that, I think what we've done at a distribution network level, there's a lot of knowledge that could be shared in looking at how we can do that at transmission level for transmission substations and the like. If you go on to the next slide, please. This was as a world first in terms of the way that we developed the consortium developed the technology and how we demonstrated it at PNDC. So as I mentioned earlier, the way that we are set up really helps us to both look at the digital side, but also the physical side. So we have a rack set up in PNDC, which uses all of the equipment that's provided by the network. And we helped to coordinate that in terms of some of the testing. So kind of the key learnings for us really was around how, by doing it in this sort of safe, controllable environment, we had a lot of issues earlier on that managed to figure out through the configuration. A lot of the performance monitoring that we had was looking at the approach to the different protection schemes. So having a look at how we do that in the virtual environment before rolling it out into some real substations was quite important. And again, one of the biggest things for this is around interdisciplinary experience. So having come from the DER background, that's something that we're talking about a lot when it comes to looking at semiconductor applications. There's an awful lot of interdisciplinary experience that's needed when we're looking at incorporating these new technologies in. If you go to the next slide, please. Another one I wanted to flag today was the LB Engine project, which is linked to one of the topics that John mentioned earlier. So this was some work we did with Scottish Power Networks. Again, it's a distribution network level, but looking at how we can implement smart transformers on the network and some of the benefits of those. So John put it quite well in terms of some of the benefits that this gives you in terms of looking after some additional functionality when we have more assets connected into the network. If we go on to the next one, I can just talk a little bit about how we approached it at PNDC. So we had one of these transformers on site, connected it up to our network, and also connected in a number of the test assets we have on site to validate a lot of that functionality that John mentioned earlier in terms of voltage control and power sharing. This has now been deployed at a location over in Falkirk, just east of PNDC, and it's been great to see that go from the early stage development work that John highlighted in terms of the design and development that Scottish Power did with the supply chain, and then also move through into PNDC, where we could help validate it, de-risk it, touching on some of what Biddy said there about that really is about how we can help reduce cost by showing these things in a safe and controllable environment, and then get them out there with confidence that they're going to work first time. And it was really good to see that happen with this particular case study. So if we go on to the next slide, please. I'm just going to fire through a few items from colleagues who are working at the University of Strathclyde on both semiconductors and superconducting devices. So the first one on the next slide here is around some work that's been done by our power electronics drives and electrical conversion group on Black Start using in a kind of distributed resource environment. So the work that was done again with Scottish Power Networks was around looking at when we have this transition to renewables that we've gone through and are going to continue to go through, how we can use grid connected converters to help in black start scenarios. Obviously the recent incidents on the continent shine a light on this being much more important as we go forward. And hopefully there's some functionality of these devices that we give that would either prevent that from happening or help us recover quicker. So there's a lot of work done in terms of understanding the issues of the network impact and understanding how the technologies could help address that. But then one of the key aspects of the project was demonstrating it with the equipment we have in the lab, both using real-time demonstration of the digital modeling of the network, but then also using grid forming converters demonstrated and the tri-phase equipment that we have. So if we go on to the next slide, it's just got a bit more information on at the top the system that we were replicating, and at the bottom half of the screen some information on the setup that we had. So on the left we've got the real-time simulation running, connected through using power hardware in the loop to the power amplifiers that we have in the lab, demonstrating different parts of the control system. So there's a link again at the bottom of this if anyone would like some more information. And just to finish up on the next one, just again on superconducting cables, it's nice again to see we already covered some of the supernode work as well. So there's a lot of work to be done on superconducting in terms of its not only the applications but the material aspects of it. So the lab that we have here at Strathclyde, if you go on to the next slide, it shows some more of the kind of practical testing environments. Next slide, please. Yes, so the applied superconductivity lab. So this is more about motors, but it gives a bit of an image of some of the equipment we have on site and the temperatures that we're working at. So when we talk about high temperature superconducting, it's still very cold. We're down at 77 Kelvin. But the way that we're set up at Strathclyde in terms of testing some of these technologies, both with current flowing through them, but also from a materials aspect, has been quite important. And setting up some of the prototypes around that. So there's a lot of good experience, and hopefully we can share some of that with those that are interested in any follow-up. But just to finish off on the final slide, please, we're open access, as I said, so please do get in touch. There's a lot that we would like to do in this area across PNDC and Wider University to kind of help with both the modelling, simulation, and validation. So hopefully that was a good taster of where our thinking is with this and some of the work that we've done to date. More than happy to share more in the future if you'd like to get in touch. Thanks for your time.
Thanks so much, Dan. Stay right there because we're going to ask all of the speakers to sort of come back online, as it were, so we can get into the Q&A session. If you have not done so yet, it would be great if you can pop a question in. I'm sure the speakers are probably not welcoming me asking for way more questions, but it will be great if we can get some questions for the speakers going. One to probably kick off on that we've seen touched on a little bit in the Q&A, both in a question and one in a statement. And Vidi, this was probably one that you raised as well. Is that balance between where network innovation lies and where R&D is? Because obviously they can be at very different scales and at very different stages. So what is the sweet spot where the networks start to take over? It would be good to hear from each of you on your thoughts here. Don't all fight to start. But I see, John, you're unmuted, so I might pick on you.
Okay, thanks. Yeah, preempted that. Yeah, absolutely. I think that now's absolutely a challenge that we see. As you say, we're down, clear of that beginning part of the supply chain. I think it's probably more a case of how we structure and balance any project together, right? Especially with the TNOs, and just trying to understand what their role is and what ours is. And I think TNOs are there more as that sort of application system validation lead in there, not the technology creator. I think that's where we work with the rest of the supply chain to do that. I think Dan mentioned more than once, and hopefully I did, in terms of that de-risking it. And that's where the support of the TNO actually is there to do that. We frame projects absolutely around that higher TRLs. We start to look at 5 to 7 and have a clear roadmap as to how we go slightly further than that. We absolutely move away from that fundamental research, TRL 3 and 4. That's why, we kind of do those internal projects to try and absolutely do that bit ahead of any consortium forming for projects and funding calls like this. So yeah, technology developers, RTOs handle R&D, IP generation, and then we just work out what that clear roadmap is when we've tried to de-risk as much as we can.
Thanks, John. And just on top of that as well, just to pair with another question that we had, we stated we want blue sky thinking. We want, try to really have a think of how you can get maybe more shifting the dial in this space a lot quicker. So most people might hear that and go, well, okay, we're looking at advanced technology development and it's probably sitting at the lower TRL level. So for the rest of the speakers, maybe have a think on what do you consider probably blue sky in this area for really pushing the dial through SIF? Dan, Vidi, you're off the hook, John.
So I'll go very quickly. I genuinely do believe that TOs play a good part from all stages, and the TOs will drive. If you take any existing technology about a transformer or about a cable, the TOs are interested in the materials. The TOs will be interested in how they age. So the actual involvement early on is very important. And I also think that there can be two pathways. Your OEMs are heavily accelerating the technology, and the TOs are heavily needing understanding. So they both have to happen in parallel for me. And I think that's where SIF is really interesting. It almost brings everyone into that room. Your initial stage, and that's why I kind of use that word de-risking, right? Instead of a TRL, almost just like everyone sits in one room and kind of think like, do you know what? Let's just leave out that part. I want to know more about B, C, and D, because that's the one that's important for me. And we'll push that through, knowing that your OEMs and the technology providers are working aggressively to kind of accelerate that TRL as well. So yeah, it's a funny space, and I think SIF has been positive for that for sure. That stakeholder engagement, almost that taxonomy of, do you know what, concentrate on those three to begin with. And that's what I kind of think as an academic institution. So you have to kind of think about the full life cycle process for me. Else you end up with a great product that will be there. And then you'll be like, well, what about 10, 15 years? What about asset management? What about condition monitoring? Do you know what I mean? So yeah, hopefully that's kind of answered some of the things.
Yeah, definitely.
Maybe just to give a supply chain side of that. So I think that was a good perspective from the networks. I think there's a lot of requirements development to be done in this space that is going to influence the entire supply chain right down to the wafer level that John talked about. I think one of the things that we can do through SIF is try to help cross that divide from the very early stages of the supply chain through to the device being out there in the field somewhere. There's a lot of requirements in terms of its life, which would be inherently affected by how you manufacture it. And I think maybe if there's some projects that can help get that stakeholder engagement going, that would help us ensure that the supply chain is there for the networks to pull on in the future.
You're in a bit of trouble there, Dan, because you raise a really good point with supply chains, which means I'm going to have a specific follow-up question just for you. And that is, are there any particular areas where you see some critical supply chain problems that we need to get sorted now?
So I guess for me, it's probably a scale and cost. If we're talking about challenges, so the work that we did in DER tried to address both of those. I think if you were to look at from as a UK procuring, I think we're looking globally, but we're not the only ones doing that. So I think there's the balance of trying to make sure that we are being strong in that respect when we're looking internationally in terms of how we make sure that we're getting a chunk of that supply chain, but also trying to build that locally. I know that's not always part of the requirements for these types of calls, but I think it's making sure that we're aware and getting a good understanding of the blend of maybe the more kind of traditional products, but also some of these smarter products that we're going to need so that we can cover all the bases in the short and the long term.
Thanks, Dan. Fiddy.
Training, people understanding it's new technologies. It's not how do you get people on board? Suppliers are there, obviously the product will come, but whoever's using it at the end of the day needs to know about it. So there needs to be an inherent balance of basically saying, can we upskill those who want to be involved as well. And that simultaneously has to happen, because I do feel like that kind of gets a bit maxed out, almost like, oh yeah, we're almost at about how do you semiconductors, let that be semiconductors, let that be solid state transformers, let that move on to a completely new insulation, cryogen, refrigeration. All of these are new areas that the network would have to kind of pick up fairly quickly. So you have to also think about that within the mix as well. It's not just pure technology, if that makes sense. It's not just the wires, it's also the people who understand that. But yeah.
Can I offer a quick comment on the first point around the network's appetite for R&D? So this is why the SIF is here, and we have an agile approach to de-risk some of those elements for the networks to do that, to allow them to do that. One example is a fantastic project we had called Comms Connect, which was with the PNDC actually. There was a large R&D element to that project. I'm sure Dan could attest to that. But they went through the discovery and alpha stage, and then they realized that actually there was some telemetry R&D that needed to be done before it could come back into the networks where UKPN would adopt it. So because there was an agile approach to the SIF, they did the discovery of the alpha, then there was a pause. They were able to go and explore funding through DSIP to develop that element. The UKPN was still involved sponsoring the project. And then once they've completed that telemetry R&D, it will be ready to be deployed in the network. So I just want to testify that R&D and low TRL levels is not a barrier to succeeding with the networks and getting sponsorship. Yeah, that was it really.
Sorry. To complement that, Beth, we just got a post from Simon Stromberg on you need to be very clear on the use case and the problem solved, because 90% of the challenges related to delivering net zero does not require a moonshot. So it's also may not need blue sky necessarily, and a lot of these problems are things that we can pull together in more creative ways to address some of the more incremental changes that add up to that 90% that can make a big shift as well. And coordination would obviously be needed there. With that, thank you so very much for all of our speakers for joining us. Appreciate you have very busy weeks and you've joined us here to shed some light on some of the work that you're doing. So definitely thank you for coming on board and sharing your insights on the webinar. We are going to shift into bringing Dan back into the, not Dan, sorry, you can go off, Matt.
Got right there.
You got very scared there, yeah.
You're welcome
Matt.
to, Dan.
So over to you, Matt, so we move into the problem statements exercise.
Cool, fantastic. And thanks so much for such great presentations from all the expert speakers there. So, okay, so for everyone else, now is your chance to really roll your sleeves up and get heavily engaged with some doing. So hopefully everyone's got access to the platform, see that in the chat. You've managed to get registered. For those who haven't, please kind of get stuck in. And I just want to share screens and give you a quick product guide and give you a feel for how the platform works, what you need to do and why it's important. So I will just flip over into this. If I could get a quick notification that that is showing up okay, that would be great. I'll assume if no one screams too loudly that we're there. Okay, great. So essentially what you're looking at here is the Strategic Innovation Fund's Ideonomy. What is that? That's really a problem book. And we're really working off first principles here and, taking advice from Einstein. If we've got an hour to save the planet, we'll spend 55 minutes thinking about the problem and 5 minutes thinking about the solution. So that's why we're focused on the problems. You will see here that there are 159 problems in the problem book, and they cover the 3 challenges that we're piloting with the SIF down here. So that is essentially what's called these strategic themes. You can see advanced transmission. We've also been doing a lot of work with consumer-centric grids and whole systems. So those last 2 are not the focus for today. We're going to purely focus on the advanced transmission challenge. So what can you do here? So ultimately, with each one of these problems, this is an interactive problem book. And we really want you to engage with the problems that are already there, as well as add problems that you think need to be solved through this SIF challenge. So how do you engage? You'll see these little thumbs up, thumbs down icons. This is really about helping the SIF to understand what the community thinks are the most important problems. So use the thumbs to prioritize. That's why they're there. If there's a challenge in here or a problem in here that you think is completely nonsensical and doesn't belong in the SIF, then down vote it. If it's okay, Javier, I'll come back in a second on the questions. I'll just do a quick run through. Give me a couple of minutes, and then I'll be there. So the other buttons that you've got here then is this button. So this is essentially the collaboration button. And what you can do here is ultimately, if you see a problem that you want to collaborate with other, it might be other academics or other industry players around, you have to click that button. Now, what we do is we'll send that data back to the SIF. So as they move from problem identification into ideation and kind of mobilizing projects, they will take that data and form groups and help project consortia to form. So that collaboration button is really, really important. And if you want to view each specific challenge, all you've got to do is basically click on it. And we can see here that people have been active already while we've been going in. So this is just the advanced transmission challenge. These are the problem statements that just relate to that specific challenge. And the first thing is get in and have a look at what's already here. So have a read. You can do a few different things as well, diving into the problem statement. So I'll just show you that quickly now as well. So if you click view problem details, it will actually bring up a little bit more information about the specific challenge. And also each problem also has a little WhatsApp group in here. So for some of the newer groups, some of the newer problems, there haven't been discussions, but for some of the older ones there have. So you can use that discussion feature to kind of refine the problem, ask questions to who submitted it, etc., etc. So that's kind of how you deal with what's already on the platform. What happens if you want to add something in? It's really simple. You just come up here to this add problem button, click add problem, and then all you need to do is write the title. And most individuals use a how might we ... type problem statement. But if I just pick something here, so how might we design, spectrum intelligent wireless systems that say self-optimize in real time across congested, contested, or dynamic transmission environments. If I pop that in here, you've then got two options. You could either complete it with AI or complete it manually. Most people complete it with AI. You just click that button, and then what it will do is essentially look at the problem title and then write a full problem statement for you in a couple of seconds. You can edit this problem statement once it's done, but it's really designed for high speed, high accuracy problem identification. And then all you need to do is put it under a strategic theme. Obviously, in this case, it will be advanced transmission. And then you've got two options. Either you publish the problem, in which case it will go onto the ideonomy. Everyone who has access to the ideonomy will be able to see it, interact with it, discuss it, etc., etc. Or you can move to this option, which is about sub-problem breakdowns. Now, this is an experimental feature. So if you click on this, you'll have the option to ask the AI to create sub-problems from your main problem. It normally takes about 60 seconds. Sometimes it will give you 3 sub-problems. Each will have its own problem statements. Sometimes it will give you 7 sub-problems, somewhere in between. And sometimes it will just return this is a hard nut to crack that the AI hasn't been able to work out how to break it down. So you can then publish after the sub-problems have been created, or if it breaks, you can come back and essentially publish your original problem statement. So that's essentially how you engage with the platform. We do want to start using this now, so please do add in your how might we problem statements, start engaging with what's already in there, but we don't want to rush you too much. So this will be available until the end of the month. And just to be really, really clear, how we use your data is like we will share your data with the SIF team, and they will then use it to essentially inform ideation and create these consortia. And because we're a cross-sector collaboration platform, we also look at other ideonomy instances that might be interesting for you to connect as well. So we're trying to join the dots across the whole system and across multiple sectors. So That's basically all I wanted to say. If anyone does have any questions or they're having any issues logging in, please feel free to contact me directly. Unfortunately, I can't see the Q&A, so apologies if people have been asking questions and I haven't been able to respond to them. But Masao, happy to hand over to you to sort of facilitate any questions or take us on to the next stage.
All good, Matt. No questions coming in from the Q&A. I know we had a little bit of an issue with the screen being smaller because all of the speakers were spotlighted, but once we removed the spotlighting, you got to see the full screen. And apologies about that. But we will then come back with the slides from the SIF webinar main bit. Charlotte, if we can jump straight to the problem statement. And then we will go into our next part, is where we're looking at a forward look. So here I'm going to ask Beth to come back on and give you a forward look of what's next in the ideation program. What can you expect in terms of the webinars and workshops, particularly the workshop following this one, where we channel those ideas and problem statements that you're placing onto Ideonomy and moving them into sort of actionable ideas that can then probably progress into projects and SIF applications. So over to you, Beth. You're on mute, Beth, sorry.
Oh, my bad. So the next workshop will be on the 18th of June. That's when we're planning to bring the networks along to this. So please make sure you register for that one. It'll be excellent. We've got 2 new webinars and workshops coming up. We've got one on green gas injection. So if you have worked in the gas industry, this would be a great one for you. And then we'll have another workshop to be confirmed in September on that whole systems piece to tie everything together. So please keep an eye out for notifications and updates from the SIF. Next slide, please. So the webinars are more of a way to understand the challenge, and I would say the workshops are where we really start to build those consortiums to put bids together. Next slide, please. These are all the ways you can engage with the SIF. I know there was a question about getting contacts with the networks. We can't give out personal contacts with the networks because of GDPR, but you can submit an expression of interest, and that will give you updates on events where the networks will be, how you can engage with them, top tips, etc., etc. So please register on the QR code below. You can follow our podcast, you can follow our newsletter, and you can just keep up to date with things coming out of Ofgem as well. Next slide, please. Thank you for listening. And if you have any feedback, please let us know. I'll hand back to Masao.
Thanks so much, Beth. Yes, so if you want to get in touch with any of us, the SIF team is here. We also can support that through the Carbon Trust. Like we said, this is just one stage in the ideation process. We do have the workshops. We do take those ideas with assessment to connect the right people to try and hopefully funnel in the applications and try to get good innovation on the networks. So if you have any feedback on how this is run and how we can make it better, there's a QR code for you. If not, and if you had an amazing time with us and the speakers, thank you so much for joining us here, and we will see you at the next webinar, if not sooner, at the next workshop. Thanks so much, everyone, and have a great week.